Hello, this is the Tepid Coder. In this video I want to continue talking about SQLite a little bit. At one point in the previous video I talked about how if you start a transaction and do a bunch of inserts, it's a lot quicker than simply doing a transaction with autocommit and doing a bunch of transactions in quick succession. So I'm actually going to set up a project where I do like 10,000 inserts, let's say, and see how long that takes with and without transactions. So I'm going to include chrono so I can benchmark. I'm going to include those streams so I can basically do something like standard V format 2, right? I'm also going to do iterator for the same reason. Anything else I need? That's looking pretty good. I'm going to do main here. Let's look for where I'm doing some inserts, actually. Oh, there's insert right there. Okay. And I think I did a reset. I did. Okay. So what I'm going to do here is once I've found the data, I'm just going to steal this right here and stick it inside of a new scope and a new loop. So I'm going to say... Okay. I'll start here. For sti equals 0, sti less than, say, 10,000. sti plus. Okay. So we're going to keep inserting 10,000 times. And before I do that, I want to say standard chrono, let's do system clock, time, point, TP, start. So I'm getting a start point, standard chrono, system clock, and it's going to be now. So whatever the time point was before I started this, I'm getting that. And then afterwards, I'm saying standard chrono, system clock, time, point, TP end equals going to be standard chrono, system, clock, time, point. Wait. That now. Okay, I should just copy and paste that. Standard chrono duration is going to be double. And it's going double. Come on. Standard, let's do milliseconds, so milli. Oops, milli. Call it dir elapsed. Oops, elapsed ms. Okay, equals standard chrono duration cast to standard chrono milliseconds from TP end minus TP start. Okay, now I can finally say standard V format 2. We're going to go to cout. We're going to say, oh, I haven't made that yet. I'll have to make that in a second. I'm going to say it took as a float that many milliseconds to insert 10,000 records. Okay. Now I need to do standard format args. Over here. I'm going to do dir elapsed ns.count. And I have to do make format args and use v format because this cannot be determined at compile time. We don't know how long it takes to execute at runtime during compile time. Okay, the other thing I need to do too is in main function when I first start is say standard stream iterator type character. Initialize that with cout. Now I can actually use it. Okay, so let's try and build this thing. So G++, it's going to be standard equals C++ 20 at least, because I'm using, well, format for one. And also chrono, I think, requires at least C++ 17, so. Anyway, so I'm going to do better.cp out is, better, and then I also need to link in sqlite3. That ought to do it. Okay, so I made a mistake on 559. Check that out. So 559. Yep, system clock. Try again. Okay, 564. 64. Huh, main. I didn't actually name it. Let's call it cout. Oops. Okay. Let's see how long this takes. So it's inserting 10,000 rows right now. And I'm writing to an SSD, so it's not like writing 10,000 records should really take that long on a solid-state drive. This is all just the processing in the code that's taking this long. And I think it's because it's trying to be ASIC compliant or whatever. It's trying to be safe and make sure that what's written is actually written properly and there's no corruption. So it's okay that it's doing that. I don't mind that it's taking extra time if it means that it's going to be done correctly. But you can imagine I had something like what did I write? Tepid coder. So TEPID CODER. It's like 10 characters, right? Maybe plus a 0, so it's 11 characters. Plus like 8 for a N64, plus 8 for a double. So that many characters times 10,000, right? So it wrote that many bytes. If I wrote these out in structures that were not padded at all, and I made it as tightly packed as possible, including that 0, I think. I can't remember if I included the 0 a second ago, but it'd be this many kilobytes. Anyway, it took, how many seconds was that? About 46 seconds. 46 and a half seconds. So let's go down to here. Make a note of that. Yeah, 46 and a half seconds. Now what I can do is I can say, let's see, SPTR DB, I'm going to do get database. I'm going to store that in a new variable, sqlite3 db equals this. I'm going to say sqlite3 exec. It's going to be begin 0, 0, 0. And I can do the same thing down here after the for loop ends. sqlite3 exec. Commit this time 0, 0, 0. Okay. So we'll see if that works. Okay, I messed up somehow. Oh, right, oops. I need to actually pass the database handle. I have a different project where I actually made an accessor method for my database class that I could have used, but I just wanted to throw this in here because I already had a users table. It's just easier to work with this project real quick. So let's see how long this takes to run now. And it's done instantly. 20 milliseconds. What a difference, right? I mean, we're talking 46 and a half seconds versus 0.2 of a second. So anyway, it's really important that you start a transaction manually and end it manually if you're going to be inserting a lot of records. This is only 10,000 records too. Imagine if you're doing 1 million or 10 million or something. Like you're converting from one database to another database. Anyway, if you found this useful, please give it a thumbs up. Consider subscribing for more content like this. And if you have any questions or suggestions or any other just general thoughts, I'd love to read them in the comments. And I will catch you guys in the next one. Have a good day. Happy coding.